Hey guys, welcome. This is the discriminant video. We've talked about quadratic equation, and now we're going to talk about the discriminant. So I want you to write all of this down while I read it. Here we go. Quadratic equation have two, 1 or 0 or no real number solutions. Before you solve a quadratic, you can determine how many real number solutions it has by using the discriminant. So discriminant is actually the part of the quadratic. It's the part under the radical sign of the quadratic. So right here in red they show it. The discriminant is this piece. So the discriminant of a quadratic can be positive, 0, or negative. So write that down, and then you're going to write this box down here, and basically stating if the discriminant is positive, then you're going to have two real solutions. If the discriminant is equal to 0, it means you can have one solution. And if the discriminant is negative, you're going to have no solutions. Okay, so write this whole box down. Let's get into some examples. Okay, so this one asks me how many real number solutions does this equation have? I don't have to actually find the solution, it just asks how many solutions. So all I have to do is first get it into our standard form. Now our standard form is ax squared plus bx plus c equals 0. This is not in that form, so I'm going to have to add the 5 over. So I'm going to get 2x squared minus 3x, and I'm going to add the 5 over. And now we are in regular standard form. So from here I can write out my a, my b, and my c like I'd be solving this equation using the quadratic. A is 2, b is negative 3, and c is 5. Now, I don't need to do the whole quadratic equation, but let's just go ahead and write it out. Anyways, the negative boy couldn't decide if he wanted to go to the radical party. He didn't want to b square and miss out on 4 awesome chickens. That's what you guys said. All over 2a. Now, the actual discriminant is just this part right here, so I don't need to solve any of the other pieces, just that piece. So we can go ahead and fill in just that part. So b squared, it's going to be negative 3 squared minus 4 times a, which is 2, times c, which is 5. Okay, so negative 3 squared, that's going to become 9, minus 4 times 2 times 5, which is 40. And we're going to end up with 9 minus 40, which is negative 31. Because the discriminant is negative, we're going to have no solutions. We're going to have no real number solutions. And if you think about it, this makes sense. That means basically this whole answer is 31. Negative. And what's the problem with having a negative under the square root? Well, the problem is you can't take the square root of a negative, so we have no real solutions. So this graph might look something like this, where it never hits the x-axis. We have no roots, x-intercepts, solutions, or zeros. I can't hold this and do that. Okay? Let's look at one more. Okay. Let's go ahead and try this one. Again, not in standard form, so I'm going to go ahead and subtract the 7 over. And my a, b, c values. I don't know why I did another line there. There we go. We get 6, negative 5, and negative 7. Okay. Now, I don't need to write out the full equation here because I just want the b squared minus 4ac. That's all. So we're going to plug it in. b is negative 5 squared minus 4 times 6 times negative 7. Okay, so this is going to become 25 Then we got 4 times 6 times 7. Well, they're two negatives, so it's going to become positive 168. And add that to 25, we're going to get 193. Now, again, I don't need to know, but this is a positive number, and so I am going to get two solutions. So positive, so we're going to get two solutions. So most likely this graph is going to look something like this, where it hits twice somewhere. Where, I don't know, because we didn't actually solve it. Okay, so two solutions. I'm going to clear this real quick, and I'm just curious, what are my answer choices? Let's see. No solution, one solution, two solutions cannot be determined. Well, it can be determined, and the answer is two real number solution. And that's what we came up with. All right, so discriminant is just part of the quadratic, which we've already learned. So, ciao.